So, good day. Thank you all for coming. Oh, I thought that there is a very interesting lecture in the other hall. Why are you all here? Just kidding, just kidding. Let's go on. So, my name is Franjo Žilić. I'm developer and system integrator at a company called BISS. And today I would like to talk to you about the missing gold mine or the application logs we have. So, why talk about logging? We use logs all the time. We use logs to troubleshoot how our application servers are working, how our services are working, how our databases are working. We write logging to debug our software, which we use every day. So is this all there is about logging? Just use it to help us set up the systems and troubleshoot it when something is wrong. So the conventional way we all look at the logs is something like this. SSHing to another server, looking them in less or cut, copying them over, looking them in some kind of a text editor, which is somewhat bad if you have logs over a gigabyte. Or even grabbing something, but then you lose context. How about a different view? How about if we view our logs something like this, as a set of graphs, as a set of numbers, as a set of indicators which can tell us how our application is behaving. So, meet the family, elk. Oh, not that elk. This family. Elastic and the related ones, Fluent and Flume. So, what is elk? Elk is a stack developed by a company called Elastic, which consists of ElasticSearch, Logstash, and Kibana. I put a star here because Logstash is somewhat of an optional feature in this, and you can replace it with other two you saw in the previous slide, Fluent or Flume. So let's see what each one of those is. ElasticSearch itself is our database. It's a document-oriented, it's distributed, it's sharded, it can be replicated, and you can have time-based indexing. So you can partition your data based on hour, day, month, however you define it. It's based on top Java and Lucene. And if you heard about Lucene, you know it's an indexing system, solution written completely in Java, and it's really fast for searching in your information. So the next part of the family from Elastic is Kibana, and we can think about Kibana as a user interface for our database. It's colorful, it's small, and it has a lot of graphing functionalities built in. So we have pie charts, we have histograms, we have bar charts, and it ties in directly into the Elasticsearch server. And there's Logstash, which is the parser. So for example, you have your standard Apache logs, and you want to visualize them. You want to get some more meaning out of all that data, which your Apache server is already generating. You can use Logstash to parse the data and to format it and to send it to Elasticsearch. It uses Grok, which is somewhat of an extension to the regular expressions. Each Grok is comprised of several subsections, so you can concatenate multiple expressions into one large regular expression, but you're not going to see something like a big, unreadable regex. And it has plugins for nearly everything. It has input plugins from file, from TCP, from rsyslog, AWS logs, whatever you need. And output plugins also not only for Elasticsearch, but also for the databases, regular ones, Postgres, whatever. So, parsing logs, if you're just looking at our current way of logging, we have textual logs. We use something like this in Logstash. We have an input filter, for example. We say it's a file somewhere, we watch it, and we parse it with this. This is Grok for entire Apache access log parsing. It's going to format the data and going to forward it back to the Elasticsearch. Or we can parse it like this. This is something which you might see. And when you see a regular expression like this, please run away. This actual regular expression is a parser from FluentD, which is used to parse router and firewall traffic. So it's actual working one, but if you have to write something like this, run away. So we can talk about parsing the logs, writing log files. But then we have a parser, a shipper. We have some systems that are in between us and actual results. And if something breaks in that chain, we can lose data. Also, parsing with regular expressions for text files, it's not as flexible as we might want. What can we gain? We can implement a custom solution for our application. It's not that difficult. You can write a serverless filter or use Spring AOP to create your data, create your log statement, populate it with all the information you know at that point in time in that application, and push it to the ElasticSearch server. This way you get a customized log where you know what your data is going to be, and you can omit certain data fields, omit certain parameters, add another one, so your log statement doesn't have to be the same every time. If we were doing this with classical logging, then we would have standard syntax for all log statements in the application, and this is not really flexible, does not scale. So what would be the benefits? We suit the logging for our application need. We can anticipate our analytical needs, we can anticipate our problems, and we can work based on this one. We can extract more analytical data out of custom logs when we put additional information which might not need at this present time, but might be beneficial for us in the future. And we get near real-time event tracking. With parsing logs, you always have some kind of a delay between the data being read and stored in ElasticSearch. If you're shipping the logs directly from your ElasticSearch, from your application to the ElasticSearch server, you eliminate this additional data pathway and additional latency. So I would like to talk about some real-world examples here, what we did in a couple of companies I worked for, how we used both parsing the logs and custom logging to extract extra value from our logging and from our existing data. For example, tracking HTTP traffic, tracking user activity, and tracking third-party API responses. Let's start with the HTTP data. On company I worked for, we had part of the services hosted on AWS, EC2. Another part of the services was hosted locally. The website itself was an online betting company, and in that kind of work you have a lot of competition. Website scraping by itself is a popular means of getting the data from other betting sites. A lot of the data which was served from our systems was not compressed. And we wanted to find the reason why, because our systems were configured to serve the zip data. We did a custom parsing for the logs of the Nginx server. We added a couple of extra statements in the log statement of the Nginx server so we can know when the Nginx is compressing the data. We dumped the data through through Logstash, through some VPN pipes on our ElasticSearch servers. We collected data over a couple of weeks, and then we did the analysis. I can say here that ElasticSearch itself is extremely CPU hungry when it's searching. So we were running this on a couple of servers, I think quad cores and some 16 gigabytes of memory. And you can see up to 8 threads per server utilizing 100% of the CPU when searching. We are searching a very complex query here. It was like somewhere around 30 different restrictions in this query, because not all data was compressed by Nginx. Some of the data was pre-compressed. And this took like 4 to 5 seconds on 12 million records. So it was really fast to get the data. It was not just getting the data, it was getting the analytical data out of it. It was getting the aggregations, getting the graphs straight out of the database. We realized after some searching through graphs, through stacks, through bars, eliminating some false positives, that the most of the uncompressed data stream was coming from just 2 IP addresses. When we did the trace routes and the whois lookups on those IP addresses, we realized it was 2 competitors, one in Croatia and one foreign. What you can do, you can then block those IP addresses or just block sending non-compressed data to them, and thus reduce the bandwidth costs on your systems. This is a real-life example how we reduce the cost on AWS. Next is tracking third-party API responses. The application we're currently developing is connecting to some 20 different web services and REST services, and is just transforming the data and passing it to the customer. Monitoring all those systems is crucial for us, capturing all the requests and responses, putting them into the context of this user, tracking errors that occur on those services, and response times from those services is vital in tuning. We realized by monitoring those services that we have one crucial endpoint which is required to load most of the data, which takes 30 or more seconds to complete. By removing that service from the initial load, we can reduce the load of the application from over a minute to under 30 seconds. This is all what we got from custom storing logs about endpoint responses in Elasticsearch. And here's some real-world data about it. This is analysis we did post-mortem at one point, analysis of failed logins and their causes, because the customers did not know why they had so many failed logins. We're talking about 50% of total logins, and this is those 15% over a period of a couple of weeks. We saw that most of them was invalid username or password. So it's not a service error. So what would be benefits of using Logstash stack instead of commercial solutions like Splunk, QRadar, or whatever else you have? It can be installed on premises and in cloud, so it's enterprise friendly. Most enterprises don't like their data to be somewhere off-site. If you're storing their data on-site, then they're going to allow you to have more of it, even if it's not anonymized, which is going to be a great help for you when you have to troubleshoot your application. There's no additional software cost involved. The entire Logstash is fully open source and free. There is no maintenance cost involved, no recurring licenses, and it's fully customizable. Unfortunately for Elasticsearch, for this stack, you do have to install and configure everything yourself. There is no magic one-button install which is going to do for you, which is one of the drawbacks. And there is no such thing as enterprise support. For example, certain customers prefer to use software solutions which they can call up and say, hello, something has been broken, can you please come and fix? Now, another example, what you can do, you can track the responses from your own applications. You can have your data stored in Elasticsearch in such form that you can track whatever the user did in the application. As I said, Elasticsearch is really fast at indexing the data and really fast at getting it. As it is a document-oriented system, it has certain limitations, especially if you're coming from the relational database standpoint. Updating the documents is a bit tricky, and there is no way to correlate the data between different fields in the same document or different fields in different documents. You can just do the analytics on one field in one document. The search itself is fast. There's a lot of built-in functions, aggregations, and metrics. You can split your data by time interval, by ranges, by custom filters. You can define what type of data you want to, how you want to display it to the customer, so you get the data from the Elasticsearch itself, prepared for graphing. So even if Kibana itself is not the best UI for your customers, you can provide them with a custom UI, easily developed, because the database itself gives you the data prepared for displaying on Angular, for example, D3 charts, or whatever you want to use. Metrics that can be commonly used are min-max, average count, distinct count, percentiles rank if you really want to. And all this data is being returned to you nearly instantaneously. You can display the data in pie charts, in graphs, in line graphs, in area graphs, in bar charts if you want to. You can split the charts in Kibana. So you can get a lot of interactive information about the data you have stored in your Elasticsearch system. It's logs for you to troubleshoot, to point out problems, to predict problems, to analyze, and to present to the customers. So you can use the existing systems, you can use your applications to give your customers extra value and help yourself, especially if you have a distributed system, when you have customers logging into more than one server at the same time, getting data from 5, 6 servers. Trying to grab through all those logs to find out the problem can be really difficult. If you put all the data at one place, in one system, which is distributed, which can be scaled easily, you can access it from one user interface from Kibana. So, clicker is not working. What? If you already have your data in your logs somewhere on the servers, you don't really have to customize your application. But I would like to see from you examples, and I would like to see this stack being used further on in the future so you can present your customers with the value and present yourself with the value. Try to reduce costs. Try to anticipate problems. See which endpoints are slow. See what your customers want more, what are they accessing more often. Put that in a more prominent position in your web page. This can be all done by analyzing the logs. And it is problematic if you have to analyze it in a text format. When you're working with ElasticSearch, you're going to find some problems. Documentation is good. There is some minor difficulties with the documentation about the Java API. You can somewhat correlate the classical standard search API with the Java API. And although the ElasticSearch itself does not have schema as such, it has mapping hints. For example, if you don't say for a certain data type, for a certain part of your object, that it is a numeric type, ElasticSearch is going to assume it's a string, and then you're going to lose all the metrics that can be done on the numerics. So even though it's schemaless, it does require some schema hints. Okay. I kind of burned through to my presentation, so sorry. This is still, yeah. Now, by itself, this system is powerful. But we, as developers, you can make it more powerful. You can make it to suit your needs. You can customize it as much as you want to. The performance is not the issue. Storage is the only problem. ElasticSearch does take a lot of storage. But the performance, as I said, we got 12 million requests we analyzed, and most of the analysis was done in under 5 seconds. A complicated analysis, splitting by days, splitting by endpoints, splitting by requests. We analyzed that we served APK files. Okay, they cannot be zipped. We can ignore them. We can build dynamically. We don't have to pre-program everything. We just have to give it data. And the analytics can give us the visual responses that we as humans can interpret more easily. Just seeing a bunch of numbers on a screen does not mean much for us. But looking at graphs can give us a clear indication where is the problem and how can we resolve it. What time is it? The interface itself, the Kibana, is great for developers. It's easy to install, it's small, you just run it from your own machine and you can get the data out to the ElasticSearch. But if you want to present it to your customers, you might even want to consider to develop your custom UI. Kibana itself does not have any security, does not have any simplified search engine. It's all pretty much native ElasticSearch querying in a nice interface. And you do get nice graphs from Kibana right out of the box. But for your customers, that might be too big. Developing a custom UI should not be a problem. You can get it fairly easily because the data comes already pre-structured for you. You don't have to query, structure the data, analyze it yourself, and then present it. So if you ask for a histogram based on dates, on how many distinct users for each day, you can get this right out of the box with a simple query. So any questions? I would like to ask if you have any ideas. Have you used it? Yes? With? I didn't hear you. I didn't hear you with what?
Okay. Can you hear me now?
Yes.
Do you have any experience with Greylock, and can you compare it with ElasticSearch?
No, I don't, unfortunately. Unfortunately, I don't. Most of my experiences are based on ElasticSearch in different installations, in different situations. So I don't have any experience with many other solutions because most of them I run into problems that I cannot install at a customer site. Unfortunately, most of my customers require the data to be installed on-site on their servers.
Okay, I have 2 more questions, if I can. You said that only you can analyze one part of data with ElasticSearch. You can't cross-reference with other sources, right?
No, once the data is in Elasticsearch, it is this way. So you can analyze, you can say, give me a count of distinct users by this field. But you cannot say, and join this with something else or fetch some extra data from other system. So the data what's in Elasticsearch is available for you to search. So if you want to get more data to analyze, to compare, to display, you put more data in. You can have a processing pipeline, you can put the data on a queue, you can process it asynchronously, you can store it then. So put the data up front, put as much data up front.
Last one, some real-life comparison based on your experience on storage capacity and like example, amount of data and storage.
Okay, I do have something. It's going to be ballpark figures, but if I'm not mistaken, for like 2 gigabytes of textual logs, it did take up to 8 or 10 gigabytes of indexed data. So it's depending on how you index your data and how you analyze it, it can be factor of 5, 4, or something in this ballpark. It all depends on your indexing and all depends on the structure of the data. Any other questions?
Yeah, let's say I have tons of logs from previous year and I want just to run Kibana on it. Can I avoid Elasticsearch? And if not, how would you go with it?
No, you cannot avoid Elasticsearch because the Kibana works only with Elasticsearch. But you can have your logs from last year, run it, split it across 5 machines, run 5 separate instances of Logstash, put them in Elasticsearch, and analyze them then. So the engine is based on the database itself. The database itself is actually the analytics engine. The Kibana is actually just the user interface that displays the data to yourself.
Apart from logs, you also mentioned metrics. So what? Sorry.
Louder, please.
Sorry. So apart from logs, you also mentioned metrics. So what metric formats are supported?
Metrics, I said, are on a custom solution. So you can put whatever metrics you want. You can have an amount of user hits as a metric, a total count of users in a time range. That can be a metric. And this metric is available in real time. So there is nearly no lag from putting the data in Elasticsearch to it being available to you. So we're talking about delay of maybe a second or 2. So from putting the data in till it's indexed and they're available for you to refresh. So metrics are defined based on queries, based on searches, and based on the type of a metric or analysis as you want to put it. You can display this as a number on your screen or as a drop counter or a chart, whatever. So this is the metric. Metric itself in Elasticsearch means a type of analysis. If I caused some confusion, I apologize here. Any other questions?
Is it possible to define an alarm that when triggered runs a certain action, sends an email or something like that?
Okay, not by itself. There are triggers in Elasticsearch, and there are ways to getting some correlation between the data, but it's slow. What you do have an option. You have an API. If you have another system that does probes, for example, Nagios or Xsinga or Zabbix, for example, they can run probes against your agent and it can query the Elasticsearch, is going to get results in a second, and you can use alarms on this. So Elasticsearch, Kibana, Logstash, collection and analytics, indexing, and then it's up to you what you're going to use the data for and how you're going to use it. It's not a pre-built solution. More questions? At first, we used Kibana 3. We moved to Kibana 4 because 3 was no longer developed. Kibana 4 actually had some improvements in data display. For example, Kibana 3 had problems when displaying the data in the IP address native format, while Kibana 4 can display it automatically. So generally, we are using Kibana 4 right now, and that's about it. Dashboards looked better on Kibana 3, I agree. But we're all going for some kind of bright, shiny, fresh look, not those dark looks of the previous years. This is some kind of a trend in development. Any questions? Suggestions?
you.
Comments?
Yeah. Applause. Okay, starting next lecture at 3:25. So, yeah. In 7 minutes.